Welcome to the grand finale of WitBlox Young Inventor Techfest 2021 organized by IIT Bombay. Let's check out the journey of Stuti and Alekha from Mumbai.
My name is Stuti. I am 16 years old and I study in the 11th.
Hi, my name is Alekha and I'm 17 years old and I study in the Cathedral and John Connon School in the 11th grade in Mumbai, Maharashtra.
Hello, I am Stuti.
And I am Alekha from Mumbai, Maharashtra. The biggest problem faced by Alzheimer's patients is irritation due to memory loss, causing depression in patients and caregivers.
Our solution, Memory Map, 3D maps the space, recognizes objects and people, and navigates the patient to the object and location through audio feedback with our novel AI model that works as dynamic memory.
Memory Map is designed on on-chip and programmed on Raspberry Pi using Python. A YOLO V4 model is used for object recognition, allowing the AI model to recognize when and where the object was last seen.
The device can then be used for finding objects with in-house navigation. We have used the Unity engine along with Fusion 360 for creating a 3D floor plan. IMU probability density function and Python application programming provide a map and a real-time virtual path as patients' inability to remember simple information such as locations of objects creates irritation and depression.
Built-in auditory assistance helps users to communicate with devices. Entire data sets are saved in an Excel sheet for recurrence and future use, using XLRD and XLWT for the file management system. Memory Map also uses a NumPy model for facial recognition, alleviating grief of patients and family due to their inability to recognize familiar faces.
As per our research and testing aided by Dr. Jyoti Sangde's insight, we believe this solution with an accuracy of 92% will be efficient and helpful for Alzheimer's and other geriatric memory loss patients. Before building the physical prototype, we looked into the various difficulties faced by Alzheimer's patients to understand how we could best assist them with our project. We decided to aid them in three major areas: navigation for object finding, facial recognition, and object detection and recognition. The video feed recorded by our smart glasses is constantly analyzed. The footage is fed into our machine learning model, which has been trained on several images of various people and objects. The NumPy model for facial recognition assigns numerical expressions to the characteristics of the faces that can be compared to determine their similarity. Our NumPy algorithm recognizes objects. The object's name, location, date, and time of recognition are constantly recorded by analyzing neighboring objects and using the DateTime library. This data is then entered into an Excel database using XLWT and XLRD. On forgetting a person's name or misplacing an object, the user would give a voice command requesting a name or guidance towards the object. Audio feedback would help the user identify faces. For navigation, the device would detect the last known location of the object, the patient's current location and orientation, and a digital map of the house for reference would be drawn up. The patient and the object would be mapped on a 3D model of the house using Unity and Fusion 360, and a route would be automatically created to guide the patient. For our microcontroller, we decided to use the Raspberry Pi because we needed something that was cost-effective, fast, compatible with all the modules we needed for our project, and that could handle heavy processing.
We were inspired to choose this prototype because we both know patients suffering from Alzheimer's disease, and we've seen the immense pain and impact it has caused for both the patients and their families, who also act as caretakers at times, when they're unable to recognize people or do simple daily tasks like navigate to a pair of glasses or find a bottle that they've left somewhere. And due to the incurable nature of the disease, the only way to help these patients and families is to make life easier for them. So we decided to make a prototype of a device that does exactly that and aids Alzheimer's patients with daily tasks. The glasses, using image processing and machine learning, 3D map out the location of both the object and the patient to navigate them to any object that they have misplaced, help the patient to recognize familiar faces, and assist with the identification of locations based on surrounding information. This allows the patient to become more self-sufficient and independent, reducing their irritation and likelihood for depression. We hope to be able to improve the accuracy and efficiency rate of the prototype to a stage where patients and families can actually use this as a product. We also want to work on the wearability of the glasses so they're better suited for Alzheimer's patients who are mostly over the age of 65 years old and are easy to integrate into their daily life. This project can also be expanded and adapted to assist other geriatric and dementia patients suffering from memory loss. One really funny memory from developing the prototype was when we were working on the facial recognition aspect of it, and while we were writing the code, we swapped both of our names in the array that would recognize each person.
So when Alekha was in front of the camera, it would detect Stuti, and when I was in front of the camera, it would detect Alekha.
And we were really confused by that and could not figure out what was going wrong for a really long time. So that was really fun.